Example 3 for the notation of it. So whenever you see this notation, this is the notation that means the derivative of, let's say we'll write it over here, the derivative of whatever is inside of those brackets with respect to x. And for right now, everything we do is going to be a derivative with respect to x, so that with respect to x part is not really that important. But when we get to some of the more advanced stuff that we do with derivatives, it won't always be with respect to x whenever we get into some related rates and stuff like that. So I think of that top part telling me to find the derivative, and then the dx tells me with respect to what variable, but it's always going to be x for you guys right now, so it's nothing to worry about. So this means find the derivative of whatever is inside of the brackets. And you'll notice this does not have any values here. It doesn't tell us at a point. So we cannot use the limit definition that we were using yesterday. We have to use the one that we learned first. So we have to use that general form, that limit. Instead of a delta x, I'm going to use a h. It really doesn't matter whether or not you use a h or a delta x. AP tends to use a h a lot more often. Our textbook uses a delta x. So I'm going to use a h here. So limit as h approaches f of x plus h minus f of x all over h. And of course, if you use the delta x instead of the h, it's the same formula. So for this problem, this would mean we would have to do the limit as h approaches 0 of the square root of x plus h plus 1 minus the square root of x plus 1 all over h. So there, what we did is we just put, this was f of x plus h, so right there where that x was, we put x plus h instead. And then we subtracted the function, which is just what we were taking the derivative of there. So in order to do this, we have to multiply by the conjugate to rationalize here. So we're going to multiply by the square root of x plus h plus 1 plus the square root of x plus 1. And we're also going to multiply by that same thing on the bottom. And when we do this, we're going to distribute here. We'll get x, limit notation. I'm going to hold on to that. Limit as h approaches 0 of x plus h plus 1. And then we'll have minus x minus 1. Make sure you distribute that negative to the x and the 1. And that'll be over h times square root of x plus h plus 1 plus the square root of x plus 1. And so these cancel, and then I'm going to go ahead, the h's are going to cancel after you get that other stuff canceled. So if we go ahead and plug in 0 for the h, we'll we'll have 1 over the square root of x plus 0 plus 1 plus the square root of x plus 1, which is going to give us 1 over the square root of x plus 1 plus the square root of x plus 1. And what do we get when we do the square root of x plus 1 plus the square root of x plus 1? Yes, it is. It is 2 times the square root of x plus 1. A lot like if you're going to add x and x, you would get 2x. But sometimes a lot of times students write that as like it's been squared, or don't combine those there because somehow it just kind of hits a little bit funny there. Alright, so this is your derivative, 1 over 2 square root of x plus 1. So in a case where they don't give you a point that you're looking at, you have to use that limit definition of a derivative here. The limit definition of a derivative at a point where it's f of x minus f of a over x minus a, that can only be used if you're looking at a specific point. Okay, questions? Okay, so we're also going to look at writing equations of tangent lines. So we did point slope form the other day in here, correct? What were we doing? Me neither. What were we doing? I think it was. Yes, it was the graphs we were doing in Decimus. You're right. So these point slope form is what I'm going to have you use. Sometimes I guess we could add this. Sometimes some versions might look like this. M times x minus x1 plus y1. Sometimes they'll look like that instead. So just take that y1 over here and move it over to this side. I don't care which version of it that you use. Either is fine. So, we have to write the equation of the line tangent to f of x equals square root of x minus 2 at x equals 2. So, whenever you are using point slope form, when you're writing the equation of the line, you have two things you have to know. You have to know x1, y1, which is a point on the line, and you have to know m, which is your slope. So whenever we are given an equation and we're asked to write the equation of the line tangent to f of x equals square root of x minus 2 at x equals 3, we need a point on the tangent line, and then we need to know the slope of that tangent line. So I'm going to pull up the graph real quick here of this. So we have f of x equals square root of x, what was it, x minus 2. And then I'm going to graph the point 3f of 3. So this is the point we're looking at right here on this graph. We want the line, the tangent line that goes through that point there. So let's say I didn't have the graph. How would I find the points, the coordinates of that point there? I know the x coordinate is going to be 3. How do I find the y coordinate that goes with it? Plug in 3. That's all you got to do. Anytime you need the y coordinate that goes with the x coordinate, you plug it in. Whenever you're doing these problems, these end up on free response questions a lot. Please, 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 you must label this. F of 3 equals. And then you can plug in square root of 3 minus 2, which is going to be square root of 1, which is 1. Actually, and if you want, you could just say f of 3 equals 1 if you do all of that in your head. That's fine. But you need to label it f of 3 there. And so our point, I'm going to call it the point of tangency, which is just our point on our tangent line there, is at 3, 1. So the point's fairly straightforward to get. For the slope, we must remember that the derivative of a function gives you the slope of the tangent line. That's what it gives you. So in order to be able to find the slope, we're going to have to find the tangent line at x equals 3. So we could use the general limit definition of a derivative, or we could use that derivative definition at a point, because we have a point that we're looking at here. I think the one at a point is a little easier to remember. So I'm going to use that limit as x approaches a of f of x minus f of a all over x minus a. So here, my limit as x approaches, x is going to be approaching 3, and it's going to be the square root of x minus 2 minus, we have to plug in 3 here, which we actually already did, right? We just already plugged in 3, and we got 1 all over x minus 3. And so now we've got to rationalize square root of x minus 2 plus 1 over the square root of x minus 2 plus 1. And so we will get as x approaches 3 of x minus 2 minus 1 all over x minus 3 times square root of x minus 2 plus 1. Alright, with you guys, if I go ahead and cancel this top and bottom, that minus 2 minus 1 is going to be x minus 3. And then we're just going to plug in that 3. So 1 over the square root of 3 minus 2 plus 1. So we end up with 1 over 1 plus 1. So we'll get 1/2 for that. So this was our derivative. So that is our slope at that point. So we have a point and a slope. We can just plug this into point slope form. So we'd have y minus 1 equals 1/2 times x minus 3. And if we graph it, let's make sure we're right. We have y minus 1 equals 1/2 times x minus 3. That looks beautiful right there. It goes right through that point of tangency. Now, that only works at that one exact single point. If you look at another point on the graph, it's going to have a different tangent line. Questions? Alright, here's another one. This one is easier but harder at the same time. So we've got the graph above shows f of x, and the table above gives select values for the derivative of f prime of x. Write the equation of the line tangent to the graph of f at x equals -1. then graph the tangent line on the graph above. So we still need a point and a slope. And I know that my point is at x equals -1, so I know the x-coordinate of that point is -1. And it tells me that f of x is this graph over here, whereas the derivative values are given with that table. So to find the point, I need to look at the graph. All right? And so if I look at -1 on the graph, what is the y value that goes with that? What is it? I think it's -6. It's a little small. I think it's -6. And so that gives me the point that I need. For the slope, I'm going to look at the derivative. What's the slope that I'm going to use? So for this, I'll be finding f prime of -1. So that means the x value you're plugging in is -1. The f prime is the y value that you get out. So x equals -1 here. The y value that goes with that is 4. So that is the derivative of the function at -1. So we would get 4 for the slope. So this other information here, just extra, so in case I gave you a different point. But in this case, this is the table of the derivative, so you're just kind of reading it off at -1. Oh, excuse me. The slope is 4. So we've got point, we've got a slope. We're going to do y plus 6 equals 4 times x plus 1. And normally I would tell you to leave it just like this, but it does ask you to graph this, which really I guess we could probably still do pretty easily because we know it goes to this point and it goes up 4, 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. We don't really. So we'll get that graph there. You also, if you wanted, you could distribute here and get y plus 6 equals 4x plus 4, and then subtract that 6. So y equals 4x minus 2. I think my graph's a little off there. I think I counted a little too. Okay. Questions? Alright. Moving on. Another type of line that they occasionally will ask for. On the old free response questions, they used to ask for normal lines. On the new free response questions, they never asked for normal lines. But in the new course description, it talked about a normal line a little bit. So I'm going to throw this in here just in case. A normal line is the line that's perpendicular to a tangent line at the point of tangency. So, like for example, if we look at that graph we were just looking at, do you guys remember what to do if you want perpendicular slopes? Parallel lines have the same slope. So if I wanted a parallel line and the slope was 1/2, I'd make the other slope 1/2. Perpendicular, anybody remember what that one is? Let's write that down. Perpendicular slopes are opposite reciprocals. Or you run a flip and change the sign. So like on that last one that we did with this graph here, if that 1/2 is my slope, so if I flipped it and made it 2/1 and changed the sign so it would be negative, then it would look like this, -2 times x minus 3. So this purple line here, that would be my normal line. It's the line that is perpendicular to your point of tangency. I don't really know what you need a normal line for or why we need to know how to do it, but I'm afraid that you might possibly see it and it's really not much different than a tangent line. All you got to do is remember to flip and change the sign. So let's do this problem here. All right. Write the equation of the line normal to the graph of f of x equals 1 over x plus 2 at x equals 3. Okay, so if first let's get our point. I think our point is the easiest to find. So to get the point, you're just going to plug in 1 over 3 plus 2. So you get 1/5. So that means that our point of tangency is at 3 1/5. Our derivative, let's use that limit definition of a derivative. So limit as x approaches 3 of 1 over x plus 2 minus, and then when we plugged in 3, we got 1/5, so we're going to have 1/5 here, all over x minus 3. So we'll get common denominators here, so I have to multiply by 5 on top and bottom for that first term, and I'll multiply by x plus 2 on top and bottom for that second term. So that will give you the limit as x approaches 3 of, so we'll have 5 minus, it's going to be minus x minus 2. That negative has to get distributed to both of those numbers there, all over, or let's see, over 5 times x plus 2 over x minus 3. And dividing fractions is easy as pie. Flip the second and multiply. We're going to get the limit as x approaches 3 of, let's see, that's going to give me 3 minus x over 5 times x plus 2 times 1 over x minus 3. That's right here. That. I can almost cancel, but not quite. So, Liliana, what could I do there to get the 3 minus x and the x minus 3 to cancel? Factor out a negative. So if I take out a negative, that gives me the negative x plus, so these will cancel. And I will get negative 1 over 5 times, I'm going to go ahead and plug in the 3 here, 3 plus 2. So I would get negative 1 over 25. And this was my derivative, so this is the slope of the graph, or the line. So we'll write it y minus 1/5 equals negative 1 over 25 times x minus 3. And we'll just leave it like that. Okay, questions? Oh, yes. Flip and change the sign. So, instead of negative 1 over 25, I should get positive 25. Thank you, Harper. And you can see one of the major mistakes made whenever finding a normal line is to forget to do that and just find the tangent line. So, this would be our normal line. Checking to make sure you guys are paying attention. Did that on purpose. I did that a lot. Keep you on your toes. Alright. Questions? Alright, we got one more. Okay. So this one requires quite a bit of thinking here. So I'm just going to graph what they've given us. So x squared plus 4x. Let's get rid of this stuff. And 2x plus y equals 8. Alright, so we have to find a tangent line to this graph that would be parallel to that line. So, send this over to the So, up here, I can do something really nifty that you cannot do on your own. I could take this line right here, and I could just say, about right there. Right, if I'm trying to estimate where this is at. So, about right here is where it looks like I've got a tangent line that just barely touches. But, you're going to have this non-calculator, and that, I mean, it looks like it's right at negative 3 maybe, but I feel a little nervous about declaring that for sure without having another way to back that up. So first of all, let's do this. I don't know this point right here where these two cross, but I could find the slope of this red line fairly easily. So if I've got 2x plus y equals 8, what do I do to find the slope of that line? Any ideas, Lily? What do you think? What's normally when we graph a line, what form do we use? Y equals mx plus b, right? And so it is solved for y. So if it's solved for y, I know what the slope and the y-intercept are pretty well. So if I just solve this equation for y, subtract 2x, and get y equals negative 2x plus 8. Now can you tell me what the slope of that line is? It would be negative 2. So the slope is negative 2. So that's the slope of this red line right here. So going back to math 1, we know how to find that slope of the line. We can just solve it for y. Y equals mx plus b. Just read that slope off. So what else do we have about a function that tells us the slope at a point? What calculus-y thing do we know that gives us the slope of a curve? It is our derivative, right? So if we could find the derivative of f of x, then we want to find where that derivative has a slope of -2. So can we use the slope at a point rule, the f of x minus f of a over x minus a? Not if we don't know this point. And I got a good guess at this point, but I don't know what the point is. So for this, you would have to find the derivative of f of x equals x squared plus 4x. But you're going to have to use that limit as, well, let's do the h approaches 0 of f of x plus h minus f of x all over h. And so for this problem, that one's going to be a little bit long. We're going to have the limit as h approaches 0 of x plus h squared plus 4 times x plus h minus x squared plus 4x. So here, this part is the f of x plus h, and this part is x squared plus 4x. All over each. So we're going to have x squared plus 2xh plus h squared plus 4x plus 4h minus x squared minus 4x all over h. And we want to cancel anything we can cancel. The x squared cancels with this negative x squared. Our 4x cancels with our negative 4x. And so everything in the numerator has an h with it, so I can factor out an h. I'll have 2x plus h plus 4 all over h. And those h's will cancel. And then I just plug in 0 for my h, so I get 2x plus 0 plus 4, or just 2x plus 4. I'm going to use this notation right here for that. That's the derivative of x, or that f prime of x. So that f prime of x, the derivative of f of x, that is the slope of the tangent line. And what do we need the slope to be? We need it to be -2 so that it will be parallel to this red line that has the slope of -2. So what we can do here is we can take our derivative that we just found, 2x plus 4, and we can set it equal to -2. And when we do that, we can solve. We'll subtract 4 from both sides. We'll get 2x equals -6. We'll divide by 2. So x equals -3. So -3 is the x coordinate of your point of tangency. So I feel reasonably assured the y coordinate is -3 also, but let's say that I don't have a graph to look at here, because a lot of times you may not. So I know my slope is -2 for my point, I know my x-coordinate is negative 3. How do I find that y-coordinate of the point? Plug it in. What do I plug it into? I do not plug it into x plus 4. Because that, look what happens if I do. I get 2 times negative 3 plus 4. That's negative 6 plus 4, which equals negative 2. That didn't look right on my graph, and that is also the slope. Because the 2x plus 4, that's our derivative, so that gives us the slope at negative 3. So if I want to know the y-coordinate, I've got to go all the way back to the original problem way up here. Okay? So when you're looking for a point, and that is one of the big things I see students getting mixed up, so I'm almost glad that you said 2x plus 4. If you hadn't, I would have said most kids do that instead. X squared plus 4x is what you want to plug into. So for your coordinates, you're going to plug into the original. So, so f of negative 2, and notice how I'm labeling that so that graders can follow my work. F of negative 2 is going to be negative 2 negative 2 squared, so what was it, plus 4x, plus 4 times negative 2. So it's going to give me 4 minus 8, which will give me, you do negative 3, thank you. That was not what we need to do. I was thinking this is not right. Okay, negative 3 will be negative 3 squared negative 3 squared plus 4 times negative 3. So that's going to give us 9 minus 12, which will give us negative 3. So our y-coordinate of the point is negative 3. And so it was asking for the tangent line, so we'll have y plus 3 equals negative 2 times y plus, x plus 3. And that is the equation for this line right here. That one had a lot to it. Okay. Question. Alright. Your homework, I kind of remade these notes because in the future I want to do 2.1 first and then 2.2, even though I did the other notes first. You have already done these 4 right here, but I've put them on there to remind myself next year when I'm teaching this that I intend to include that. So you guys are just doing 25, 27, 29, 34, 36, 45, and 46. Okay? So you've got a pretty good amount of time to work on it here. Also remember test corrections are due on Friday, so if you're welcome to work on those also, as long as you're doing some math.